Hey everyone, welcome to Pluto. Today let's take a look at objects in Javascript, and more specifically, referencing and copying of objects. Now, what is an object? It is a built-in, non-primitive data type used to store key-value pairs. Now we know objects are using key-value pairs, but what are non-primitive data types? In JavaScript, there are two types of data types, primitive and non-primitive. Primitive data types contain these numbers, string, boolean, null, undefined, symbol, big int. Now, symbol was introduced in ES6, big int was introduced in ES 2020. And if you look closely, we can see that these data types store only one kind of value. We can discuss symbol and big int in another video. Okay. So take a look at number. It can store only one number. If I take a string data type, it can store only one value of a string. Boolean also does the same. Every other data type also stores one value. Now, non-primitive data types are derived from primitive data types. And object, array, function, date object, regular expression, these data types are derived from primitive data types, which means they can store multiple values. For example, an object can store multiple key value pairs. Now, if we look here, this person object, it does have a property called name and a property called age. And this property is storing a string value, and this property is storing a number value. Now, we can also create objects using plain curly braces without using this object syntax. And if I say person1 is equal to this is perfectly valid way to create an object. Now, these non-primitive data types are stored differently from a primitive data type. By that, let me show you first. Let me just create a string. It says, oh, just copy and paste it here. Now, if I check if they are equal, here this one. If I check if they are equal, it says true because they are storing the same value. So A and B can be evaluated as the same. Okay. Now, if I do the same for this object and has the exact same content, name is equal to John and age is 30, and if I check, they are the same, we get an interesting result. It's evaluating to false, which means person 1 and person 2, even though they contain the same data, they are not evaluated as the same. But what if I say that, since the content is same, what if I say person 2 is equal to person 1? I'm just copying the contents of this person 1 to person 2, and then I'm checking if they're the same, they are equal, and I can see that it's true. Oh, okay, fine. So I can copy the contents of person 1 to person 2 just like this. Now, what if I want to add another property to person 2? Let's say person 2 has a salary. Let's say 30,000. Sorry, 20,000. Now, if I log what's in person 2, you can see that it has name John, age 30, and salary 20,000. But if I see what's in person 1, I can see that it's also having this property salary, and it says 20,000. But I only modified the property of this person 2 object. Now, why is this happening? This is because of the way JavaScript stores these objects in memory. Now, let's go to the diagram. Okay. So let's see. If I initialize a variable like this, const a is equal to an object which has an ID and an address property. And what happens is JavaScript has a memory called stack memory, which is used to just used for many purposes, but mainly for storing primitive data types. And it also has a memory called heap memory, which is where objects are stored. Now, when this happens, when this initialization assignment happens, this object is stored somewhere in the heap memory. Let's say it's stored at the location 0x001. And this a variable is stored in stack. And now what is the value of this a variable? It is this address. This address is stored corresponding to this a variable, which means this a variable is pointing to the address of this heap memory location. Let me just draw to show that it's pointing. This a variable is pointing to the memory location of this object in the heap memory. So we can say that a is storing a reference of this object. Now, what happens when we say that constant b is equal to a? Now, an additional variable is added in the stack. But the interesting part is this b is equal to a. So what's in a? This thing, this memory reference. So b also gets the same reference, which means it's also pointing to the same object. Okay? Now, if we modify anything over here, since a is also pointing to the same object, it's also going to get changed in a because they are pointing to the same object. That's why we saw here, if I add a property to person 2, it's also getting added to person 1. Okay. Now, now how can we copy an object without modifying the properties of the original object? Let's see how we can do that. Let me copy an object. Paste this here. Okay. This is an object. This is the object we saw in the other example. Now, this object has an ID property, an address property, and this address property is another object. It's storing a key or a property named city. It says New York. Now we can copy an object using the object.assign method. Now, for that, we initialize another variable as an empty object, and we use the object.assign method. Now the first argument is the target. We want to copy the contents of this A object to this B object. So the target is B. And it says sources. The second argument is sources. We want to copy the contents of A, so the source is A. Now if I console log B, and if I check if both of them are pointing to the same object, now B contains the exact same properties as A, and it's not pointing to the same object in the heap. So that's why it says B. But interestingly, if I check equality between a.address and b.address, I can see that it's true, which means this address object is the same for A and B, which means if I change something in B, it's also going to change something in A. Let me just change b.address.city is equal to, let's say, Delhi, and let's see A and B. Now the change is affected in both A and B. So even if we can copy an object using this object.assign method, it's not properly copying every property. If a property is another object, it's only copying the reference of it. That's why it's changing if I change a property in one of the objects. Now, this same behavior can be achieved via a spread operator in JavaScript. Now, a spread operator It's something like this, which means take everything out of A and assign it to B. Now, if I console log B and I console log A is equal to B, I can get the same result. It's not the same, but A dot address and B dot address points to the same. So if I change A dot address, B dot address is going to change as well. But to properly copy an object, we have to use the structured clone method. Okay, so to do it, we initialize B is equal to structured clone of A. Okay. And now if I check the same here, now if I check the same here, it says false. Let's check the error address and the address are the same. It's also false, which means A dot address and B dot address are not pointing to the same variable. Okay, so that's it. That's how we can copy an object to another object without changing the properties of another object. Okay, let me also show you a method to check if a key is present in an object. Now, I used to check if a key is present in an object using the object.keys method. Okay, object.keys method. Now to check it, console log object.keys of, let's say address is present in this. It's true, which means now this object.keys method returns an array, and I'm checking if this address is in that array. But only recently I learned that there is an easier way to check if a key is present, and it's so simple. Address in A. That's it. I can check if a key is present in an object simply like this. See, it returns true. So that's it. That's pretty much about this video. Hope you learned something new today. I will see you guys in the next one. I'm a little tired today.